Hi everyone, and welcome to our video on two mortgage problems. So these are present value problems as well, where we would be paying off some type of large sum just over an amount of time. All right, so let's break this down. Let's see how these work. So in this example, it says Linda wants to buy a house worth $180,000. She plans to make a down payment of $80,000 and then take out a mortgage at a monthly interest rate of 3.1% compounded monthly for 15 years. What will be her monthly mortgage payment and how much interest will she have paid at the end of the 15 years? All right, so just like most of these problems that we started to deal with in finance, as soon as I see compound or as soon as I see payments, I'm thinking, let's get our TVM solver going. So the TVM solver, oops, I clicked the wrong thing. So the TVM solver, so here was hidden. Okay, so behind. But all I did was type in TVM solver into Google, and then I usually use the GeoGebra one. Because I think it's nicely formatted. Okay, so there it all is. And then I'm just putting it to the bottom. Okay, so what I'm doing is copying these variables. So we have N equals I% equals present value equals PMT is payment equals future value equals, and then our payments per year equals compounds per year equals. And again, these are should be the same in all the problems that we have. The common problems, they're the same. Now on rare cases they might be different, but I don't have any of those, and they're hard to find, so typically they're the same. Okay, and then the other thing that we do have to remember is that this capital N is the number of times compounded per year times time. All right, so let's start to fill this in. Now, in mortgage problems, let me add this at the top. Okay, so that usually involves some type of house. Okay, so mortgage problems, we need to make sure we have the correct present value. The present value is the amount after the down payment. Okay, so on this problem, let's just kind of mark it up here. Our present value, so the house is worth $180,000, but currently she plans to make a down payment of $80,000. So the total worth of the house right now minus the down payment would give us $100,000. So that is what we truly want here. Okay, so this $180,000 is the original price of the house. I'm going to just abbreviate OG house. Okay, so the original house, I guess amount, just to squeeze it in there, minus the down payment. Okay, so the original house amount minus the down payment, that is the present value. Okay, so that's what we want to put in here. Make sure you got the right number of zeros. When you write it, you always put little commas in. When you type it in, sometimes calculators don't have commas, though, so just be careful. So I've got 5 zeros. All right, and then now let's break down the rest. Oops. Okay, so let me get rid of that. There we go. All right, so Linda, so we already took care of that. And then it says, and then take out a mortgage. So this is what the mortgage is on. This is the loan. So the $80,000 is paying a lot of the house off, and then she still needs a loan for this $100,000. Okay, so a mortgage at a monthly interest rate. So monthly tells us 12 right here, 12 right there. The interest rate, 3.1. And then compounded monthly, again, already taken care of. But let's put it in the N. Almost forgot that. For 15 years. Okay, so 15 right there. And then it says, what will be her monthly mortgage payments and how much interest will she have paid at the end of the 15 years? All right, well, let's break it down. What will her monthly mortgage payment be? What will be her monthly mortgage payment? Let's say that that's like our number one thing. Number one. And then number 2 is the how much interest will she have paid. Okay, so we want the payment, so we're trying to find that. And we just put 0 in as a placeholder. And then, well, the future value should be 0. So the goal is to pay off the house, so 0 eventually should be the loan. And they might say amortize like the loan, so it's in the second one, but this is to pay off the entire loan. Okay, so we do have everything we need for the calculator, at least for this first step. So now I'm back to my TVM solver, and we'll do 12 times 15. Remember, the calculator does it for you. And then 3.1, and then 100,000. 1, 2, 3, 4, 5 zeros. Payment will leave as 0. Future value is 0. And then here we've got payments per year, and the number of times compounded per year is 12. And then now we can go to the payment and click solve. And then there we go. And as a one other reminder, so the sign doesn't matter. As long as the future value is 0, the sign doesn't matter. If I did negative on that, it changes this to positive. Okay, so it usually negatives are outgoing. So it's kind of almost as if these are both outgoing in this scenario, but kind of the real outgoing would technically be the payments. So that's outgoing every month. Okay, anyway, but our final answer we would still change it to positive. So, and round it to the nearest cent. So we would put a 0 after that 4. So 695. Oops, I put the 0 in the wrong spot. Is 40 cents and 40 cents. Okay, so that is number 1. That is what will her monthly mortgage payment be. We found it. And let me just make sure I did copy it right. 695.4. Yeah. Okay, so that's correct. And then for number 2, it's saying how much interest will she have paid at the end of the 15 years. Now, when it's asking how much interest will she have paid, it's talking about on the present value. So 2, interest, I didn't spell it right. On the present value. So because the original 180,000, again, that was just what the price of the house was, but we're not paying interest on what's already paid immediately. So $80,000 is already paid. Okay, so we don't need to pay interest on that. So it's only on the present value. But the way that we want to deal with this is just we'll see. Let's write it like this. We'll do capital I for interest is equal to, let's say, the total paid minus the present value. Okay, and if you're going in order of these videos, I wrote it as like amount spent last time. So total paid or amount spent. Okay, so just kind of different wordings mean the same thing. Okay, and the total paid though, well, this is the amount that she's paying per month. So the 695.40, and you can even put the per month on it if we need it. Okay, so it's already assumed there it's monthly mortgage, so that we know that this would be per month. And then we would say, well, she's making 12 payments per year because there's 12 months in a year for 15 years. So that total paid is the payment times in. And so now we could plug all this in. So we have the 695.40 times the in. When we did that in the calculator, and we could always check it again, but it was 180. Okay, so we have times 180, and then minus the present value is $100,000. Okay, so I'm just going to use my basic calculator that's on the computer and get that. So 695.4 times 180, and we get $125,172. And then I guess that is rounded to the nearest cent. So we've got it as $125,172, and then minus the $100,000. Like that. And then now we can finish it off with the subtraction. It would be $25,172. And I'm just putting the comma there to make sure I've got the right number of place values, and I think that is good. Looks good. Okay, so that's the interest. So over 15 years, $25,000 was spent on the house. But again, probably we don't have $100,000 ready to spend immediately. So over 15 years, that's not too bad. All right, so that's it. So that's it for this one. So we have the total interest. Okay, so let's see the other variation on the mortgage. So and there's not much of a variation except one little thing. So in this example, it says Ringo closed the deal on a $225,000 house. The bank requires him to make a 20% down payment, and then he will be able to take out a 30-year mortgage at a monthly interest rate of 4.5% compounded monthly. Find the monthly house payments to amortize the loan. How much interest will Ringo have paid at the end of the 30 years? All right, well, let's see. So same deal where you start to see, compounded monthly payments. Okay, so I know my in, my I percent, my present value, my payment, my future value, my payments per year, and my compounds per year are all getting ready to be set up. And then, we still need to make sure our present value is correct. So the house is currently worth that amount. The bank requires 20% down payment, though, before the monthly mortgage can come in. Okay, so we need to find that real quick. So our present value is equal to the original price of the house. So just like before, we can scroll a little bit. So the original house amount minus the down payment. Now this is a percentage, 20% down payment. Okay, so minus, the way that we can find it, we just need to do 20% of the $225,000. This is where we would need to convert it into a decimal. So 20% is 0.2, and then our original house payment right there. So this is 20% of that amount, and then from there we could do that subtraction. Okay, so our present value will be $225,000 minus, and then I'm just going to use my basic calculator again. So 225,000 times 0.2. So this 45,000 is what is required from the bank to get the loan started. Okay, so usually they make you pay a large amount before they give you the loan. Okay, so that's just kind of like, hey, can you pay this amount first? Because if you can, then we trust you. If you can't, then, we don't trust you, and that's a bummer. Okay, so let's write this as 45,000 there. Okay, so this is the down payment right here. So the down payment, let me go ahead and put the percent, but converted to a decimal, times the original amount. Again, I'm going to abbreviate OG. So that's that down payment when they use a percent like this. Okay, so 20% down payment. On this one, it was just instantly given. Okay, so that is the one variation. That's the tweak. Okay, but anyway, let me now finish off that. So it's 225,000, and then we'll minus the 45,000, and it's 180,000. Okay, so we need to pay off. Okay, so that is the present value, and I'm just going to kind of squeal around it. Okay, so that's what needs to go here. There we go. Okay, and then now let's deal with the rest of it. So the rest of it, so we've taken care of that. So from the down payment, and then it says, and then he will be able to take out a 30-year mortgage. Okay, so usually I put the time second in the capital N, but it doesn't matter the order. But that is our time. At a monthly interest rate, so I could put 12 here now anyway, and then we could put 12 down there and 12 down there. Okay, so the monthly interest rate of 4.5%, so we've got the I percent right there. Compounded monthly, already taken care of. Find the monthly house payment to amortize the loan. Okay, so we're finding PMT. And then our future value we should have as 0. So in the future, hopefully, right, if things go well, that should be $0. Okay, so let's find that payment, and we'll use our solver. So I just need to type all these in again with something different. So 12 times 30 is 360, and then 4.5, and we have 180,000. Then the payment we'll just leave as 0 for now. Future value 0. Payments per year and compounds per year is also 0. So payment we can now solve for, and it's $912.03. All right, so we've got the payment is $912.03. Okay, so that is the monthly house payment. Again, let me just double check. 912. Yeah, that's the monthly house payment. So that's the mortgage. How much interest will Ringo have paid at the end of the 20 years? 30 years. Sorry, I'm seeing the wrong numbers. Okay, so this is our number 2. We just found number 1. And then okay, so to find the interest, I'm going to use I equals, let's put it, what we can do is look right above. It's this same deal, so it's the total paid minus the present value. And our total paid is the payments amount times the number of payments, which would be our capital N, and then still minus the present value. And so we'll substitute those in. So our payment we found from step 1, $912.03. Our number of payments was 360, so that 12 times 30. And then minus the present value. The present value is this one. Remember, don't use the original price of the house. It's only on what the loan is on. Okay, so the original house we paid off a little bit right away, and then now we're paying the rest off. Okay, and then now is where I would just use, on the computer, I'm just using this calculator because it's the fastest. So $912.03 times 360 times gives us that. Okay, so let me go ahead and write that in there. So $328,330.80, and then we'll subtract. So this amount right here, I'm going to go ahead and highlight it. So this is the total paid over the 30 years. Okay, so the total paid over the 30 years. So if somebody had $180,000 right away, then they would not have to pay $328,000. So we're kind of seeing how much we lose in this scenario. So yeah, it's a bummer having to take out a big loan like this. But again, most of us, unless we're super lucky, don't have that type of money and we have to pay it off slowly. Okay, but now let's do that subtraction. So the 328,000, 330.8, and then minus 180,000. Okay, so it's 148,330. And 80 cents extra. So that's the amount that this is kind of like the money lost over those 30 years if we could have paid off the house right away. Okay, so that's how you can find interest though. So if it did want how much was paid on the total loan, there it is in the pink. But chances are they would only want the interest. Okay, so I hope this helps. Remember, if you ever see compounded whatever, or if you see a payment of something every week or quarter or month or whatever, get this guy going, the TVM solver. So it's a whole lot faster than any of the formulas that we could have written. And I didn't even include that many formulas. I just wrote the one just to kind of see them. But other than that, I would say get that TVM solver going. Okay, so I hope that helps. If you have any questions, let me know. Otherwise, thanks for watching.